to get a little bit into this concept of wave superposition. What happens when we combine waves together? How does that combination of waves behave compared to the waves that made it up? So let's start off with two sine waves. Now we have the red one and the blue one, and you'll notice that they are exactly the same. They have the same frequency, they have the same amplitude. There is no phase difference between them, which means that their peaks and their troughs line up. So the maxima and the minima all in exactly the same place. Now this purple wave is the combination of our red and blue waves. What I want you to notice here is that when we are at the maximum for the blue and the red wave, which is 1, the combination of those two waves is of course going to be 2, because we're adding 1 plus 1. We're adding the values of the two waves. And similarly down here, when we're at the minimum of the red and the blue wave, which is -1, the combination, the superposition of those two waves is going to have a value of -2. This phenomenon is called constructive interference, which means that the two waves are adding up to give you a greater value. And this happens when the maxima and the minima of the two waves that are adding up together are in sync. This is called being in phase. But what happens now when we change this blue wave and we shift it over by pi? Now we have two waves that are out of phase. So what happens when we get the superposition of these waves? When we add them together, we will see that they cancel each other out completely. They are always equal and opposite to each other. The combination of them in this case is always giving us a value of 0. This is called destructive interference, and it happens when the waves are out of phase. And here we have the case of complete destructive interference, and this happens when the phase difference between the two waves is half a wavelength, when they are going through opposite values at the same time. The wavelength of both of these waves is 2 pi, but there's a phase shift of pi between them, which is of course half a wavelength.